Ladies and gentlemen, please welcome NVIDIA founder and CEO, Jensen Huang.
Twenty years after we introduced to the world the first programmable shading GPU, real-time ray tracing, something that was, of course, used in film rendering offline. It required that we reinvent the GPU, was the showcase demo. The first RTX GPU was called Turing. As you can imagine, we did it on purpose. It was appropriately named to unify computer graphics and artificial intelligence for the very first time. Racer RTX. 250 million polygons, 100 times more geometry, 10 rays per pixel, about 10 bounces per ray. We're using a unified lighting system for every effect for the very first time. This entire scene is completely path traced, no rasterization. We're rendering it at 1080p, 30 hertz, and using DLSS, using artificial intelligence, infer, hit it. Not bad for real time. I think it's safe to say modern computer graphics has been reinvented. The bet has paid off. While we were reinventing computer graphics with artificial intelligence, we were reinventing the GPU altogether for artificial intelligence. The GPU, when I came to see you last time, 5 years ago, most people would say that this is what a GPU looks like. And in fact, this is the GPU that we announced. This is Turing. And you guys might remember this. This is the Turing GPU. But this is what a GPU is today. This GPU is, let's see, 8 hoppers. Each one of them, all together, something like between the hoppers, the 8 hoppers connected with NVLink, the InfiniBand networking, the NV switches that are connecting them together, the NVLink switches, all together, 1 trillion transistors. This GPU has 35,000 parts. It's manufactured by a robot, like an electric car. It weighs 70 pounds. Consumes 6,000 watts by AI in so many different applications. The revolutionary transformer model allows us to learn from a large amount of data that's across large spans of space and time to find patterns and relationships, to learn the representation of almost anything with structure. We learned the representation, how to represent language, in mathematics and vectors, in vector space, audio, animation, 3D, video, DNA, proteins, chemicals. And with a generative model and the learned language model, you can guide the autoregressive diffusion models to generate almost anything you like. And so Viscom does sketch to image guided by language prompt. This one's really cool. There are a lot of people who know how to sketch, and from the sketch, and some guidance from your language, you could generate something photorealistic and rendered. The future of computer graphics is clearly going to be revolutionized. And this is really cool. Wonder Dynamics, not only is the name of the company cool, but they do pose and lighting detection and replace the actor with a CG character. It just goes on and on and on. The number of generative AI startups around the world, I think we're coming up on something like 2,000. And they're in just about every single industry. The generative AI era has arrived. Well, what's really profound, though, is that when you take a step back and ask yourself, what is the meaning of generative AI? Why is this such a big deal? Why is it changing everything? Well, the reason for that is, first, human is the new programming language. We've democratized computer science. Everybody can be a programmer now because human language, natural language, is the best programming language. The computers in the world, computing is done in so many different places. And sometimes they're used for training, sometimes they're used for inference, sometimes they're in the cloud, sometimes it's for scale up, sometimes it's for scale out. Sometimes it's for enterprise, sometimes it's underneath your desk in your workstation. There are so many different ways that computing needs to be refactored. And NVIDIA's accelerated computing will support every single one of those. But one particular area is extremely important, which is the basic scale out of the cloud. The basic scale out of the cloud historically was based on off-the-shelf CPUs, x86 CPUs. While general purpose computing is a horrible way of doing generative AI, and you could see that in just a second. And so we created a brand new processor for the era of generative AI. And this is it. This is the Grace Hopper. We announced Grace Hopper, in fact, just only recently, several months ago. 10 terabytes per second of frame buffer bandwidth and 282 gigabytes of HBM3E. Well, pretty much you could take just about any large language model you like and put it into this, and it will inference like crazy. The inference cost of large language models will drop significantly because look how small this computer is. And you could scale this out in the world's data centers because the servers are really, really easy to scale out. You can connect this with Ethernet, you can connect it with InfiniBand, and of course, there's all kinds of different ways that you can scale it out. Let's take a look at what it means if you were to scale it, take this, and now scale it up into a giant system. This is 2 GPUs, but what if we would like to scale this up into a much, much larger GPU? Run it, please. The world's largest single GPU. 1 exaflops, 4 petaflops per Grace Hopper, 256 connected by NVLink into one giant system. And so this is a modern GPU. So next time when you order a GPU on Amazon, don't be surprised if this shows up. The central processing units, or general purpose computing, was relatively mainstream. And for the last 60 years, that's the way we've been doing computing. Well, now, general purpose computing is going to give way to accelerated computing and AI computing. And let me illustrate to you why. The canonical use case of the future is a large language model in the front end of just about everything. Every single application, every single database, whenever you interact with a computer, it will likely be first, you'll likely be first engaging a large language model. That large language model will figure out what is your intention, what is your desire, what are you trying to do given the context, and present the information to you in the best possible way. It will do the smart query, maybe a smart search, augment that query and search with your question, with your prompt, and generate whatever information necessary. And so the canonical example that I'm using here is a Llama 2 large language model that is being inferenced. It then does a query into a semantic database, a vector database of some kind, and the output of that is augmented and becomes a guide for a generative model. And here, the generative model I'm using is Stable Diffusion XL. And so these 3 models, Llama 2, vector database, and Stable Diffusion SDXL, are relatively well understood as state-of-the-art and the type of models that you could imagine running just about everywhere. Well, if you were to have an ISO budget way of processing that workload, it would take, let me just choose a number, $100 million, and $100 million would be a reasonably small data center these days. $100 million would buy you about 8,800 x86 GPUs. It would take about 5 megawatts to operate that, and I normalize the performance into. Let me give you a couple of examples. This is a AI that is a large language model, as I mentioned, that will be connected to almost every single application. However, the future user interface of almost every application is a large language model. And so it's sensible to imagine that this large language model could also be a query front end to a 3D database. And so here, I find a Denza N7 SUV. Now, once you find this SUV, you might ask an AI agent to help you to turn this car, to embed this car, to integrate this car into a virtual environment. And instead of designing that virtual environment, you ask the AI to help you. Give me a road in the desert at sunset. Now, inside Omniverse, we can then unify, aggregate, composite this information together, and now the car is integrated, rendered into, positioned into a virtual world. And so here's an AI that helps you maybe create and find some manage your data assets. You also have an AI that helps you generate a virtual world around it, and Omniverse allows you to integrate all this information. Well, let's take a look at what WPP, the world's largest ad agency, and BYD, the world's largest electric vehicle maker, how they're using Omniverse and generative AI in their work. Play it, please.
WPP is building the next generation of car configurators for automotive giant BYD's Denza luxury brand, powered by Omniverse Cloud and generative AI. OpenUSD and Omniverse Cloud allows Denza to connect high-fidelity data from industry-leading CAD tools to create a physically accurate, real-time digital twin of its N7. WPP artists can work seamlessly on this model in the same Omniverse Cloud environment with their preferred tools from Autodesk, Adobe, and SideFX to deliver the next era of automotive digitalization and immersive experiences. Today's configurators require hundreds of thousands of images to be pre-rendered to represent all possible options and variants. OpenUSD makes it possible for WPP to create a super digital twin of the car that includes all possible variants in one single asset, deployed as a fully interactive 3D configurator on Omniverse Cloud GDN, a network that can stream high-fidelity, real-time 3D experiences to devices in over 100 regions, or used to generate thousands of individual pieces of content that comprise a global marketing campaign. The USD model is placed in a 3D environment that can either be scanned from the real world using LiDAR and virtual production, or created in seconds with generative AI tools from organizations such as Adobe and Shutterstock. This innovative WPP solution for BYD brings generative AI and cloud-rendered real-time 3D together for the first time, powering the next generation of e-commerce.
Generative AI is incredibly powerful. But getting accurate results customized with your secured, proprietary data is challenging. NVIDIA AI Workbench streamlines selecting foundation models, building your project environment, and fine-tuning these models with domain-specific data. Here, AI Workbench is installed on a GeForce RTX 4090 laptop, where we've been experimenting with an SDXL project. As our project gets more complex, we need much more memory and compute power. So we use AI Workbench to easily scale to a workstation powered by 4 NVIDIA RTX 6000 Ada generation GPUs. AI Workbench automatically creates your project's environment, building your container with all dependencies including Jupyter. Now, in the Jupyter Notebook, we prompt our model to generate a picture of Toy Jensen in space. But because our model has never seen Toy Jensen, it creates an irrelevant result. To fix this, we fine-tune the model with 8 images of Toy Jensen, then prompt again. The result is much more accurate. Then, with AI Workbench, we deploy the new model in our enterprise application. This same simple process can be applied when customizing LLMs such as Llama 2 70B. To accommodate this much larger model, we use AI Workbench to scale to the data center, accessing a server with 8 NVIDIA L40S GPUs. We tune with 10,000 USD code snippets and nearly 30,000 USD functions built by NVIDIA, which teaches the model to understand 3D USD-based scenes. We call our new model ChatUSD. ChatUSD is a USD developer's co-pilot, helping answer questions and generate USD Python code. With NVIDIA AI Workbench, you can easily scale your generative AI projects from laptop to workstation to data center or cloud with a few clicks.
We could create models that are mainstream today that you could use in just about all kinds of applications around your company. And you could fine-tune it with these GPUs. The fine-tuning of a GPT-3 model, okay, so this is GPT-3, 40 billion parameters, takes about 7 hours for about 1 billion tokens. And so 15 hours in a workstation with 4 GPUs, of course, takes less with 8 GPUs. And just in fine-tuning, this is 1.5 times faster than our last generation A100. And so L40S is a really terrific GPU for enterprise scale fine-tuning of mainstream large language models. You can also use it for of course, synthesizing and generating images. Okay, so generative AI for everyone. Everybody could do it now. Hugging Face, NVIDIA AI Workbench, NVIDIA AI Enterprise, these amazing new enterprise systems that are in production today. All right, let's change gears and talk about what's going on at SIGGRAPH this year. I'm pretty sure all of you have already heard about OpenUSD. OpenUSD, is a very big deal. SIGGRAPH 2023 is all about OpenUSD. OpenUSD is visionary and is going to be a game changer. OpenUSD is a framework, a universal interchange for creating 3D worlds, for describing, for compositing, for simulating, for collaborating on 3D projects. OpenUSD is going to bring together the world onto one standard 3D interchange and has the opportunity to do for the world and for computing what HTML did for the 2D web. Finally, an industry standard, powerful and extensible 3D interchange that brings the whole world together. A really big deal. Now let's take a look at why it is such a visionary thing that Pixar did. It was invented, well, I forget exactly when they invented it, but they open sourced it in 2015. And they've been, of course, using this framework for over a decade, building amazing 3D content. Well, the 3D pipeline is incredibly complicated. The 3D workflow is specialized and complicated. You got designers and artists and engineers. They all specialize in some part of the 3D workflow. It could be modeling and texturing, materials, physics simulation, animation, set design, scene composition. There are so many parts and so many different tools. And because the tools are created by different companies and largely incompatible, import and exporting data conversion is just part of the workflow. And because they're incompatible and because there's all this import and exporting, fundamentally, the workflow has to be serialized. It's impossible to parallelize that. And the converting, of course, all of this data is cumbersome and is error-prone. And so this workflow is fundamentally complex. You could argue that it was just designed to be complex. And this is one of the reasons why creating these incredible 3D animation movies are so expensive and take so much time. Well, one of the visions, the first vision, of course, of OpenUSD is to put the data at the center. Could you imagine if every single tool was natively compatible with USD? Then as a result, data gravitates to the center. Everybody can work in parallel. The interchange and conversion goes away. And instead of a serialized model, you have a parallelized spoken hub model. And so this way of doing work, of course, is incredibly appealing, and it's one of the reasons why the vision of OpenUSD has taken off. Well, there's some 50 tools available now. The industry loves the vision. OpenUSD already has a rich ecosystem. Some 50 tools are now compatible with OpenUSD natively. 170 contributors in the USD forum from about 100 companies. So you got a lot of people really interested in this, and the momentum is growing. It's being adopted in film, architecture, engineering, and construction, manufacturing, and so many different fields of robotics. We're engaged with companies in so many different parts of the industry, all excited about USD because everybody's workflow, like creating movies, is complicated. This is no different than a company who's in manufacturing, a company who's trying to build a new building. So many different specialists, so many different contractors, so many different parties coming together to build something complex. For the very first time, we have a standard interchange that can bring everybody together. So super, super exciting. Well, 5 years ago, we started working with Pixar, and we adopted USD as the foundation of Omniverse. Our vision was to create these virtual worlds that make it possible for us to bring world design into the applications that I mentioned. Industrial digitalization at the core of many things that we want to do, not just for, of course, creating amazing movies and broadcast and video games, but also to take 3D worlds, physically based, real time, into the world's industries. We felt that we could make a real impact. And so we selected USD. It was a brilliant move. The team made just a visionary move to partner with Pixar to select USD as the foundation of Omniverse. This is probably the world's first major platform, incredible database and engine system that was built completely from the ground up for USD. Every single line of code was designed with USD in mind. The platform for USD for describing, simulating, all the things that we just mentioned. And so Omniverse was designed to connect. It's not a tool in itself, it's a connector of tools. It's not intended to be a final production tool. It's intended to be a connector that make it possible for everybody to collaborate, interchange, share, live work. Okay, so Omniverse is a connector. Well, let's take a look at how the vision of OpenUSD came together. And this is just a fantastic illustration. Starting from the left here, I think this is Adobe Stager, Houdini. This is a modeling system, Maya, or animation system, modeling system. This is Omniverse, Blender, RenderMan, Pixar's RenderMan, and Unreal Engine from Epic, a game engine. Literally all OpenUSD. One data set ingested into No art, all physics. Physics make you happy, doesn't it? Physics makes you happy. Okay, well, we wanted to put Omniverse everywhere. You could download Omniverse from our website and run it on your PC and your workstation. For enthusiasts and designers, that's perfect. You could also license Omniverse for enterprise. And for enterprises that are using it across many different organizations, we even set up a managed service for you inside your company. We're putting Omniverse now in the cloud so that we could host and serve up APIs that can be connected to developers and applications and services so that you can have the benefit of some of these amazing capabilities. And so we're setting up Omniverse Cloud. Now, Omniverse, as I mentioned before, is not a tool. It's a platform for tools. It's not a tool. It's a platform for tools. And we created a whole bunch of interesting tools to help you get started. There are reference applications, and many of them are open sourced. One application, for example, that I really love is Isaac Sim. It's a gym for teaching robots, for robots to learn how to be a robot. And because it's so physically accurate, the sim to real gap is reduced. And so theoretically, you should be able to learn as a robot how to be a robot inside Omniverse. And that neural network, that software, could then be put into a local embedded device like a Jetson or one of NVIDIA's Jetson computers, robotic computers, and the robot can perform its task. Enormous amounts of waste, as we all know. $50 trillion worth of industry. Over the next several years before the end of the decade, there will be trillions of dollars of new EV factories, battery factories, and new chip fabs that are going to be built all over the world. Not to mention the enormous number of factories that are already in operation. Some 10 million factories are in operations today. This industry would love to be digital. They would love the benefits of all of our industries. But unfortunately, their industry has to be physically coherent. It's physically based. They build things, they build and operate physical things. But they would love to do it digitally, just like us. And so how can we help them do that? Well, this is where Omniverse and artificial and generative AI comes together for us to be able to help the heavy industries of the world digitalize their workflow. Just as modeling and texturing and lighting and animation and set design and so on and so forth are all done by different groups in a very complicated pipeline, this is very much the case of the world's heavy industries. Every one of their organizations, from design to styling to engineering and simulation and testing to factory building and design, factory planning to build the products, and even operating these software-defined robotics-assisted products in the future, all of this is done completely mechanically today. That entire flow could be digitalized, and it could be integrated for the very first time using OpenUSD. This is the incredible vision of OpenUSD, why we're so excited about it. If we can only augment it with real-time capability and physics simulation capability and make it so that every single tool is connected to Omniverse, we can digitalize the world's industries. Well, their excitement is enormous because they all would love to have the productivity, would love to reduce the energy consumed, would love to reduce the waste, would love to reduce the mistakes in digital long before they have to build it in physical. And so this is Mercedes. They're using Omniverse to digitalize their manufacturing lines. This is Mercedes using Omniverse to simulate autonomous vehicles. This is BMW using Omniverse to digitalize their global network of factories, some 30 factories. They're now building it in Omniverse without breaking ground and doing the entire integration a year before the factory is actually even built. Using Omniverse to simulate new electric vehicle production lines. Remember, the placement of the factory, the planning of the factory, and the programming of all the robotic systems are just incredibly complicated. In the future, entire factories will be software-defined. The factory will be robotic, orchestrating a whole bunch of robots that are building cars that themselves are robotic. So robots building orchestrating robots building robots. So that's the future, and everything is all software-driven, everything is all AI-enabled. This is BMW using AI to drive their operations. This is Wistron using Omniverse to digitalize their production line to build this machine. As I mentioned, 35,000 parts, incredibly complicated. One of the most expensive, one of the most valuable instruments that's made anywhere. And so having that line be completely robotic and automated is really important. This is Pegatron using Omniverse to digitalize PCB manufacturing. Again, this is the PCB of this incredibly complicated PCB motherboard. This is the most complex motherboard the world's ever made. TechMan is using Omniverse to test and simulate cobots. It's not surprising to you, but most cobots, most robots today are not very autonomous, not very AI-driven. Programming the robots usually costs way more than the robots themselves. I heard a statistic that the robot for a manufacturing arm for the automotive industry is something along the lines of $25,000. Not very much, but programming it could cost $250,000, which is very sensible. We would like to have AI be self-programming these autonomous limbs. So TechMan is using Omniverse to test and simulate cobots. They're also using Omniverse to build applications to automate optical inspection. Of course, for PCB lines, the cameras can be stationary. The product, the manufacturing device system is just rolling by you. But for many things like cars and other very complicated systems, the optical inspection has to follow the curvature and, of course, the various contours and shapes of the product. Hexagon is using Omniverse to connect, just as we've connected tools all over the world, Hexagon is using Omniverse to connect their own tools. This is one of the most powerful things that they observed in Omniverse. Whereas they had different groups and different teams that are in silos, and because they're incompatible tools, getting them to connect together was hard. And so this was a company organization and a company management challenge. So whatever momentum we've already enjoyed, the vision that we've already enjoyed, it's about to get kicked into turbocharge. Well, I want to thank all of you for coming today. We talked about SIGGRAPH 2023 for us is 4 things. It's about the transition of a new computing model. The very first time in decades that the computing architecture is going to be fundamentally redesigned from the processor to the data center to the middleware, the AI algorithms, and the applications that it enables. The processor we created for this era of accelerated computing and generative AI is Grace Hopper, and we call it GH200. We have NVIDIA AI Workbench to make it possible for all of you to be able to engage generative AI. NVIDIA Omniverse now has a major release with generative AI, and of course, release and support for OpenUSD. And then finally, whether you want to compute in the cloud or do AI in your company underneath your desk or in your data center, we now have incredibly powerful systems to help you all do that. I want to thank all of you for coming, but before you go, I have a treat for you. This is an anniversary, I understand, of computer graphics. SIGGRAPH has been a really special event and a very special place, and computer graphics, as you know, is the driving force of our company and very dear to us. We have dedicated probably more time, more engineering, more R&D, quarter of a century, over a quarter century, well, 30 years, dedicated to advancing computer graphics. I don't know any company who has invested so much. This industry is dear to us. The work that you do is dear to us. And if not for the work that you do, all of you who come to SIGGRAPH each year, how is it possible that AI would have achieved what it is today? How would it be possible that Omniverse would be possible or OpenUSD would be possible? So we made something special for you. Please enjoy.
It all started over 50 years ago with a simple question. What if a computer could make pictures? How could we use them? And what would they look like generations from now?
Hello, folks. I'm Mr. Computer Image.
Welcome in. I hope you're hungry.
Thank you all for coming. Have a great SIGGRAPH 2023. And remember, accelerated computing and generative AI, the more you buy, the more you save.